Hello everyone, good morning. I hope you all are good. Everyone is okay. Okay, so in today's class, what we are going to read, we are going to solve questions again from ray optics. And today, the main topic on which we will be solving question is your total internal reflection. Okay? First, we will discuss a bit concept of it, and after that, we will move on to questions. Okay? But before we go to total internal reflection, we were having one question left yesterday that we were supposed to discuss. I also asked you all to solve it and then come. Uh, I hope you all must have done it. But again, let me give you some time here also to solve the question. So take some 2 minutes of time, solve this question and let me know what answer you're getting. Okay. Hello, do the question and let me know. Yesterday in the class also we solved several questions on this concept. You know? So I hope you all will be able to solve it. And you should solve it actually. Let me know what answers you're getting. So if you look at the question carefully, let me discuss now. Anyone on the way of solving it? Anyone? Okay, no answers. तुम लोग कोशिश करो. Try doing it and let me know what answer you're getting. Let me tell you the steps. What you will do, what is the question? There is a container and that is filled with water. Okay. Refractive index of water is 1.33 up to a height of 33.25. Okay. So this height is how much? Water is filled up to 33.25. Okay. A concave mirror is placed 15 centimeter above the water. So from here, 15 centimeter above, there is a concave mirror. Now what is happening? And the image of object placed at the bottom, object is here. and its image is getting formed 25 centimeter below the water level. Okay. The focal length of the mirror is what? So सबसे पहले what you need to do, how we calculate focal length? Simply we will use a mirror formula, right? So this formula we are going to use. In the question, image distance is given, object distance is given, but we need to look at carefully what will be the object distance, because that object is kept in water, and suppose object is here now. So what will happen if its image is getting formed by mirror? Light coming from object will fall on what? Will fall on a mirror. Okay? For image formation, right? So see here, some part of the light is traveling in water and some part of it is traveling in air. Done. So object distance won't be 33.25 plus 15. It won't be that, right? Why it won't be that? Because this is different media and this is different media. So what will be the object distance? Anyone let me know the answer. You should solve it actually. We have done a lot of question on this. So now let me know what object distance you're going to write here. जल्दी से बताओ. Object distance will be what? Like this is some height is getting, some length is getting traveled in water, and refraction is happening at this point, right? This is the interface of water and air. Done. So for 33.25 centimeter distance, what we will write, real height by apparent height will be equal to what? Light is traveling from where to where? At the interface, light is traveling from this is your water to air. So refractive index of water you will write at the top, and then refractive index of air. Okay. Now apparent depth or height, whatever you say, will be equal to what? Mu air is 1. This is equal to 1. So real height by mu water. And this will be equal to 33.25 by 1.33. If you are going to divide it, if you divide it exactly, you will get 25 centimeter. If you're going to divide it, you will get what? You will get something 25 centimeter around. Okay. So object distance will be how much? 25 plus how much? 25 plus 15. So this is equal to how much? 40. Isn't it? Done. And now what is happening? Image is getting formed at a distance of how much? 25 centimeter below the surface of water. So object distance is 40 centimeter. Image distance will be how much? From here it is 15 and from here it is 25. So image distance is also how much? 40 centimeter. This is only possible if object is kept at center of curvature. That is U is equal to R. That is 40 centimeter. So focal length will be how much? 20 centimeter. Okay. The only thing that you have to do here differently is you have to see what will be the effective object distance. Why effective? Because object is kept in water and some part of light is traveling in water and some in air. Okay. So what is in air will remain as that is 15 centimeter. You know? But in water it is traveling 33.25 centimeter. We will see what will be the apparent depth for this section. Done. So that we have calculated here, and that came as 25 centimeter. So object distance is this. Image distance is given in the question. Anna? It is given that it is getting formed 25 centimeter below the water level. Done. So that's given. We don't need to apply here any real apparent concept. It's already given it is getting formed 25 centimeter below. So that is why. Any doubt? Anyone? My energy is low actually. I'm not okay. So forgive me for that, but try to cooperate, please. ठीक है, चलो ठीक है. Now what we are going to read? We are going to read total internal reflection. वो है क्या? जैसे देखो यहाँ पे एक डायग्राम दिख रहा है. सपोज कर लो इधर तुम्हारा एक मीडिया है. ये जो लाइन है ना, यहाँ पे जो ये लाइन है, ये इंटरफेस है. इट इज डिवाइडिंग टू मीडिया. मीडिया वन एक है रेयर मीडिया, एक है डेंसर मीडिया. डन. सो एक को वन बुला रहे हैं, दूसरे को टू बुला रहे हैं. ठीक है. नाउ व्हाट वी आर गोइंग टू डू, वी विल do one thing. We will allow light to fall from denser to rarer media. जैसे यहाँ पे देखो, लाइट को डेंसर मीडिया पे इंसिडेंट करना है. So you will allow light to fall on denser media, and after that what will happen, it will refract to rarer media. That we have to do. Okay. So first light that we have taken is at normal incidence. So normal is this, incident light is this. So angle between normal and incidence here is what? 0 degree. So it will not refract. It will go straight like this. है ना? अब देखो, suppose we are taking another ray which is not along the normal. यहाँ पे if you're going to draw the normal, it is at certain angle of incidence and it is getting refracted at certain angle. ठीक है? What we will keep on doing initially for this ray, I कितना था हमारा? 0 था. And gradually we will increase I from 0 to certain value. ठीक है. So as we will increase I, R will also increase. ठीक है. ये चीजें ध्यान से देखो. That will also increase. Now here we have increased angle of incidence further. So angle of refraction has increased more. Like how much more can angle of refraction increase? Like to what maximum value it can go? So let's see that. So for one particular angle of incidence, that is called critical angle. यहाँ पे it is denoted as IC. IC means critical angle. Okay. For this particular angle of incidence, angle of refraction is how much? 90 degrees. This is maximum angle of refraction. ठीक है. If we are going to increase angle of incidence beyond this, suppose now we are going to increase I such that I is greater than IC. In that case, what will happen? Angle of refraction will increase further. Then, or you can't say it is getting refracted actually. It will be wrong to say it is getting refracted. यहाँ पे क्या हो गया? Light is getting reflected. है ना? क्योंकि it is not moving on to the next media. In the first media itself, it is getting reflected back. So for angle greater than critical angle, what will happen? Light will not go into second media. It will come back to the first media. And this is called total internal reflection. So for total internal reflection to happen, I should be greater than IC. And if I equal to IC, ray of light, refracted ray of light will graze the surface. सरफेस को ग्रेज करने का मतलब क्या होता है? अलोंग द सरफेस यू आर मूविंग. ठीक है. दैट इज कॉल्ड ग्रेजिंग द सरफेस. डन. So for I equal to IC, it will graze the surface. Now for total internal reflection to happen, what should be the conditions? सबसे पहला condition should be ray of light should travel from denser to rarer media, because then only angle of refraction will increase with angle of incidence increasing. Because if it is going from denser to rarer, then only refracted ray will bend away from the normal and its chance of increasing will be there. ठीक है. So very first condition is what? Very first condition is light should travel. Light should travel. ठीक है. It should travel from where to where? From denser to rarer. First condition should be this. What should be the second condition? Second condition should be I should be greater than equal to IC. Again, equal to IC means it will just graze. It should be greater than IC for total internal reflection to happen. ठीक है. So these are the two conditions. Now we will calculate value of IC that we can do. क्योंकि for angle of incidence IC, angle of refraction is known, that is 90 degree. So at this point we will apply what? We will apply स्नेल्स लॉ. तो चलो अप्लाई करके देखते हैं. यहाँ पे देखो, फ्रॉम अ स्नेल्स लॉ, ठीक है, व्हाट वी विल राइट, n1 sin I, you just see here, for at this point we are calculating at this point. So at this point angle of incidence is IC, ठीक है, and it is in which media? One media, that is denser, so its refractive index here we are writing as n1. So n1 sin I equal to n2 sin R. For calculating critical angle, we will put I equal to IC. So we are putting I equal to IC and then R will become equal to 90 degree. क्योंकि if I equal to IC है, then R is equal to what? 90 degree. We already know that. So from here, sin 90 will become 1 and critical angle will become equal to how much? Sin IC will become equal to N2 by N. That is refractive index of rarer media with respect to refractive index of denser media. ठीक है. So on top there is a refractive index of rarer media and on bottom it is refractive index of denser media. तो याद रखना, हमेशा ही इसको डिराइव करने की जरूरत ना पड़े क्लास में. सो रिमेंबर इट, क्रिटिकल एंगल इज इक्वल टू हाउ मच? इट इज इक्वल टू रिफ्रैक्टिव इंडेक्स ऑफ rarer media on the top divided by refractive index of denser media on the bottom. ठीक है. So this is how we will define critical angle. Done. So critical angle again, if you people are students of maths, even if you people are students of biology, you must be knowing if sine theta is equal to p, then theta can be written as sine inverse p. That is why we are writing here like this. ठीक है. किसी को प्रॉब्लम है ये समझने में? किसी को प्रॉब्लम है क्रिटिकल एंगल समझने में, या फिर एनीवन हैविंग डिफिकल्टी इन अंडरस्टैंडिंग total internal reflection at all? कोई भी प्रॉब्लम है तो बताओ. वी विल डिस्कस एंड देन वी विल मूव ऑन टू क्वेश्चन. यहाँ से भी क्वेश्चन आ रहे हैं. ठीक है. सो वी नीड टू कवर दिस टॉपिक बोथ इन नीट एंड जी. क्वेश्चंस आर कमिंग. डन. नो डाउट. ठीक है. चलो कोई डाउट नहीं है. नो मैसेजेस आई रिसीव्ड. एनीवे, दिस इज द क्वेश्चन. इट केम इन 19 ओनली. ठीक है. रीड द क्वेश्चन केयरफुली. देखो, इफ यू नो द कॉन्सेप्ट ऑफ TIR, दैट इज टोटल इंटरनल रिफ्लेक्शन, concept is very easy, right? Applying this formula is very easy. Only thing while doing question is important is what? Geometry. How well you are in geometry and also how well you are in mathematics. ठीक है. So इस question में you don't need to do anything, just geometry and mathematics, more mathematics. ठीक है. So read the question carefully. Even if you're not able to find the final answer, it is going to benefit you. Take some 2 minutes of good time. Stay with this question for 2 minutes. Try solving. ठीक है. चलो बताओ. ध्यान से करो. I'm here only. Try to do something. Whatever is coming into your mind, try to apply that. Okay. Am I audible to everybody? 2 minutes. After that, I will start the discussion. Okay. So take your time. I'm here only. Don't worry. चलो, I will discuss beat by beat. ठीक है. Let's start with basic. There is a transparent cube of side D. So this is a transparent cube. Side D है. Made of material of refractive index mu2. ठीक है. And this is immersed in a liquid. Means in the surrounding there is liquid. है ना. And in this surrounding there is a cube kept. Then liquid का refractive index is given. That is mu1, and its refractive index is mu2, such that mu1 is less than mu2. So this is rarer, this is denser. Done. Now what is happening? Ray is incident on face AB at an angle theta. यहाँ पे incident हो रहा है. Total internal reflection takes place at point E on the face BC. Here it is happening. Then theta must satisfy. So for total internal reflection to happen at E, what should be the range of theta? Then, so here question is all about mathematics. How we'll solve it? Just see, देखो, to be able to solve such type of question, we should solve more number of questions. So this is just the first one that we are going to solve. तो ध्यान से आप लोग देखो. At this point, at point E, total internal reflection can happen because light has tendency to move from denser to rarer medium. Done. So it will happen. But for what range of theta? Done. Because this angle should be minimum equal to C. That is critical angle. ठीक है. एक second. So for total internal reflection to happen, ठीक है, ये जो angle है, ये angle, this should be minimum equal to how much? IC. ठीक है. And in case of IC, what will happen? Light will graze the surface like this. Done. So and maximum this angle should be what? For this light to come back into the medium mu2, this angle should be greater than IC. So let's always, while solving, we take the case of minimum. That is, for this angle, total internal reflection will start. happening or it will graze the surface. ठीक है, तो इसको IC मान लो. This is 90 and this is equal to how much? 90 minus IC, है ना, this angle, क्योंकि this is a triangle. Done. And this triangle is, this is E and this is your, suppose कर लो O है and this is P. So this angle is equal to R and this angle I am taking as IC and this is 90 degree. R क्यों लिया मैंने? This is angle of refraction for refraction happening at surface AB. Done. So R will be equal to how much? 90 minus IC. Now you just see here, if theta is higher, just try to see if you're going to apply what? If you're going to apply Snell's law at surface AB, you will see what? और ऐसे भी यहाँ पे देख सकते हो, वी हैव, जैसे ये पॉइंट है ना, यहाँ पे ही रिफ्लेक्शन हुआ है. डन. सो एक सेकेंड, let's draw the surface AB. So this one I have drawn. Here light is getting incident. This is done. And this is normal at this point. So this is angle of incidence and angle of refraction. Since this light is going from rarer to denser, it will bend towards the normal. Done. So this is angle of refraction. If we are going to apply Snell's law at this point, what we will write? We will write mu1 sine theta is equal to mu2 sine r. है ना? This one we will write. Now, if you write the value of sine theta will be equal to how much? Mu2 by mu1 sine r. So this is a constant, right? This is what? Constant. Refractive index will be constant. Now, if we are going to increase theta, if you will increase theta, r will also increase. Just see here carefully. ठीक है, जो मैं बोल रही हूँ उसको ध्यान से फॉलो करो. यहाँ पे इफ यू आर इंक्रीजिंग थीटा, आर विल ऑल्सो इंक्रीज, क्योंकि साइन थीटा इज डायरेक्टली प्रोपोर्शनल टू साइन आर हियर. सो इफ थीटा इंक्रीजेस, आर विल इंक्रीज. And if r is increasing, what will happen? If this angle is increasing, then this will remain 90 degree. So this will decrease. Done. And we have to keep it greater than IC always. Done. समझ रहे हो? We have to keep it greater than IC always. So what we should do for, if this angle is IC, for that we will have a value of R, and for that we will have a value of theta, right? And that theta and here angle of incidence must be always less than that value of theta. क्यों? क्योंकि if theta will increase, R will increase, and if R is increasing, this angle will decrease. But here this angle we have to maintain at greater than IC. So if this angle is equal to IC, for that we have a value of R, for that we have a value of theta. Done. So that will be the maximum value of theta. After that, value of theta should be less than that. Okay, I hope you have got it. So if you have got it, now by just take the value of here, and here take the angle as IC, and for that calculate here एंगल ऑफ रिफ्रैक्शन. ठीक है, तो चलो अब हम लोग फॉर्मूला अप्लाई करेंगे. सो व्हाट विल बी द वैल्यू ऑफ आईसी? सबसे पहले तो ये निकाल लो आईसी की वैल्यू कितनी होगी. सो साइन आईसी विल बी इक्वल टू हाउ मच? इट विल बी इक्वल टू μ1 बाई μ2, है ना. साइन आईसी कितना होगा तुम्हारा? μ1 बाई μ2. सो दिस इज डन. नाउ अप्लाई लॉ ऑफ रिफ्रैक्शन, दैट इज स्नेल्स लॉ एट दिस पॉइंट. So if you're going to apply it, we have got this one. So sine theta will be equal to how much? μ2 by μ1 into sine r. R का value क्या होगा? If this is IC, R will be 90 minus IC. So sine 90 minus IC. So that is equal to cos IC. ठीक है? So μ2 by μ1 cos IC. अब देखो साइन आईसी का वैल्यू वी आर हैविंग, कॉस आईसी कितना होगा? सो यू कैन कैलकुलेट. इफ यू नो साइन थीटा, यू कैन इजिली कैलकुलेट कॉस थीटा. सो कॉस थीटा क्या होता है तुम्हारा? 1 माइनस साइन स्क्वायर थीटा का रूट अंडर, है ना. सो इट्स वैल्यू विल बी हाउ मच? 1 माइनस μ1 स्क्वायर बाय μ2 स्क्वायर रूट अंडर. नाउ राइट द वैल्यू ऑफ साइन थीटा. सो साइन थीटा विल बी इक्वल टू हाउ मच? μ2 by μ1 cos IC, and cos IC is equal to how much? 1 minus mu1 square by mu2 square 1 by 2. Now try to uh, break it or solve it properly. So this is mu2 by mu1. Here it has power of 1 by 2. If it will go inside, it will get squared. You know? So this will become mu2 square by mu1 square minus, you will multiply this with this. So it will become what? This is mu2 square by mu1 square and this is जैसे अगर इस पे भी रूट डालते हो तो क्या करना पड़ेगा, स्क्वायर करना पड़ेगा ना. Done. So that same thing I have done here. So if we will multiply this this with this, what we will get? We will get minus 1 power 1 by 2. So sine theta ka value, theta is how much? Sine inverse mu2 square by mu1 square minus 1. And for this theta, here the angle is how much? Critical angle. So other value of theta should be less than this theta. Because if theta is increasing after this value, if it is increasing after this value, then what will happen? This R will increase and this IC will, this angle will decrease, will become less than IC. Then internal reflection will not happen. So our theta should be less than sine inverse mu2 square by mu1 square minus 1 का root under. ठीक है? So this should be your answer. I hope it is clear. If it is not clear, you can let me know. किसी को doubt है? इस क्वेश्चन में you needed to look at कि how we will calculate the range of theta. So with geometry we need to deal. If theta is increasing, what will be effect on this angle? That is uh, incident angle at point E. ठीक है? So that we needed to check. चलो ठीक है, तुम लोग कुछ बता नहीं रहे. Now let's do this question. This is relatively very much easy. So let me know the answer. I'm giving you 2 minutes. This is a very easy question. ठीक है? तो तुम सभी लोग solve करो. Okay, what happened? Sorry. Yeah, done. This time you should answer. Anyone who got the answer? Any answers? Okay, so what will happen here? There is a ray of light and that is incident at glass water interface at an angle I. Okay, so this is your glass water interface, right? So sorry, this line I'm talking about. At this point, what is happening? Ray of light is incident at an angle I. It emerges finally parallel to the surface of water. So finally, it is grazing the surface like this. Okay, it is going on like this. Okay, then value of mu g will be what? Done. So what we can see here, see, I is not known. R is okay. I is given in the question, so that is known. I is I done, but R is not known in the question. Done. And here you can see this R is known, right? Do one thing, apply Snell's law at this at this point first. If you're going to apply it here, angle of incidence is R, sine R into mu G, mu W, that is 4 by 3 will be equal to sine R, that is, sorry, angle of refraction we will take, that is 90 degree into 1. Why here R I have taken? Because here angle of incidence is R. By vertically opposite angle, this R and this R is going to be same. So from here you can see sine R is equal to how much? 3 by 4. So we know now sine R. Now let's apply Snell's law at this interface. So if you're going to do that, sine I into mu glass will be equal to sine R into mu water, that is 4 by 3. Now here sine R is equal to 3 by 4 and this is 4 by 3. So it will become 1. Yani ki mu g is equal to 1 by sine I. So this is going to be your answer. Okay. So question is actually too easy. Done. We just needed to apply Snell's law at these two interface. Just apply it and put values from one to one values of one into another, and then you will get the answer. Any doubt, anyone? किसी को डाउट है? चलो ठीक है. Now let's do this question. ठीक है. Those who doesn't know, for them I am telling, refractive index depend on the wavelength also, and mu is inversely proportional to wavelength का square. ठीक है. This is the fact that you will find application here. So refractive index of any media also depends on the wavelength of light, and the relation is this. Okay, let me know now. Take 2 minutes and let me know the answer. Anyone who got the answer? One more minute you are having. Solve it. Is it done? Okay, so which light will emerge? जैसे when light is incident on the interface of glass and air, as shown in the figure, if green light is just totally internally reflected, it means for green light, this angle is equal to critical angle. Okay, for green light. Then the emerging rain air contains. Just see here, sin IC for any color of light I am writing. So sin IC will be equal to how much? Sin IC का formula क्या लिखते हो? Refractive index of rarer media, that is 1 here, divided by refractive index of denser media. Let it be mu. ठीक है? So just now I said you mu is directly proportional to 1 by lambda का square. So mu equal to constant को k ले लो, k by lambda square. ठीक है? So 1 by mu will be equal to how much? Lambda square by k. So sin IC is equal to lambda square by k. Done. तो फॉर ग्रीन लाइट सपोज कर लो इस एंगल की वैल्यू कुछ थीटा है. सो फॉर ग्रीन लाइट दिस थीटा इज इक्वल टू हाउ मच? साइन थीटा इज इक्वल टू लैम्डा ऑफ ग्रीन बाय के, लाइक दैट. ठीक है. एंड फॉर अदर कलर्स ऑफ लाइट, just let's say जैसे in visible spectrum, if you remember, wavelength of light will vary from 420 to 720 something. ठीक है. And higher wavelength being red and lower wavelength being violet, and other colors will be in between. ठीक है. So if you see that pattern, that is your with geo. ठीक है. So as we will go down, what will happen? Wavelength will decrease, right? So just see here, green light is here. So for yellow light, orange light, red light, wavelength will be what? Greater than green light. है ना? For yellow, orange, red, wavelength is what? Greater than green light. And if wavelength is greater than green light, IC value will be what? IC value will be greater than theta for which colors of light? Yellow, orange, red. Understood? Critical angle for yellow color, orange color, red color will be greater than this angle because this is critical angle for green light. And for green light, critical angle, if that is this, then sine theta is lambda g square by k. And for yellow light, this lambda is bigger. So this theta has to be bigger, right? So yellow, orange, red light, this light will not get internally reflected. It will get refracted क्योंकि for yellow, orange and red light, this angle theta is less than what? Critical angle. Done. So which light will come out? Light that will come out will be yellow, orange, red. And if you go down, blue, indigo, and violet, their critical angle will be equal to how much? Sin IC for these colors will be equal to how much? Lambda. Suppose कर लो मैं violet लेती हूँ. Violet का square by k लिखो. ठीक है. So this is definitely less than that of lambda g. So this IC is less than theta. यानी कि critical angle for blue light is less than that of critical angle of green light. So if this angle is equal to critical angle of green light, then definitely for violet light, this angle is greater than its critical angle. Then, so definitely that will come inside. So the light that is coming inside or getting internally reflected is blue, indigo, and violet. So emerging light it was asking, right? So correct answer should be what? It should be A. Okay? I hope you all are getting it. किसी को कोई डाउट है? सॉरी यार, माय एनर्जी हैज बीन टू लो. किसी को डाउट है? नहीं है शायद, तुम लोग बोलते नहीं हो, ठीक है। नाउ लेट्स डू दिस क्वेश्चन, ठीक है। इट केम वेरी much time, like it came way back in 1981. So it's a very old question, but still, we need to solve this question to understand the concept. Because the one that came in 2019, okay. In that case, also we needed to find the range. Here also we need to find the range, and that is why I've included this question. So everybody, please take your time, take 2 minutes, and invest your time. Try doing it. ठीक है, करो आप लोग। Anyone who got the answer? चलो ठीक है. So let's discuss the question. There is a glass prism of refractive index 1.5 and that is immersed in water. ठीक है. Refractive index 4/3. A light beam incident normally on the face AB. So on face AB, light is incident normally. So it will go like this. You know? Since it is incident normally on face AB, won't refract. Angle of incidence is 0. So angle of refraction will also be 0 for the face AB. Now, this light will fall on AC surface. And what we have to show, a light beam incident normally on face AB is totally reflected to reach the face BC if. So, if this light is able to reach face BC, it means it is not going out, and it is getting totally internally reflected at face AC. So, let's draw a normal on face AC. So, this light is incident at an angle this. So, this angle will be equal to what? If this is theta, this is 90. and this will become 90 minus theta, है ना? And this whole is 90 degrees, so this will become theta. So angle of incidence is equal to how much? Theta. And if light is getting totally internally reflected at here, then theta must be greater than equal to IC, or it should be greater than, because it's able to reach the surface BC. That is only possible if theta is greater than IC. ठीक है? So यहाँ पे मैंने लिख दिया theta is greater than IC. Now let's calculate what? Let's calculate sin theta. So let's apply Snell's law at this point. Okay, on surface AC. Then, if you're going to apply, what we will see, sin theta into refractive index of glass we will take, and that is equal to how much? 1.5 will be equal to what? It will be, okay, so here we are going to apply what? Okay, so sin critical angle, let's calculate here. Okay, critical angle निकाल लेते हैं. So I'm going to calculate sin theta c. So sin theta c, here critical angle I'm calculating. So sin theta c into 1.5 will be equal to how much? It will be equal to sin 90. So I'm just calculating critical angle. Okay, and this will be equal to 4 by 3. So what is the value of sin theta c, or that is IC. यहाँ पे मैंने nomenclature क्या लिया है? IC. So same लिखते हैं, नहीं तो you people will get confused, है ना? So यहाँ पे लिखो IC I'm calculating. Okay. So sin IC, sin 90 is 1, 4 by 3 into 1.5, that is this. So if you're going to calculate it, uh, am I right? This is 4 by 3, right? So this is 40 by 15 into 3. So 5 times may we can cancel it like this. So 8 by 9. Sin IC is how much? 8 by 9. So we have calculated this. Now let's use this thing. Multiply this or take sine on both sides. Okay? So if you're going to take sine on both sides of this, it will become sin theta is greater than sin IC. So sin theta will be greater than how much? That is 8 by 9. So this is how we can also reach to the range of theta here. Okay? So in the very first question that we solved for total internal reflection, that was a bit more complicated because we were dealing with a case where light was not incident normally on the first case. There it was a different sort of incidence, so that was a bit more complicated. Since here normal incidence was there, यहाँ पे हमें कुछ करने की जरूरत नहीं पड़ी. Directly we went for this point, and that is why it became more easier. Done. So I hope it is clear. If anyone has any doubt, let me know. Otherwise, we will close the class. किसी के पास कोई डाउट है? ओके, नहीं है तो thank you so much for joining and for staying throughout. Anna, it was a motivation for me because I was also not feeling so well to take the class, but you all people stayed and that motivated me. That helped me to take the class. Thank you so much. Keep reading. Keep practicing more and more number of questions. Stay healthy. Take care of your health, please. And stay positive also. Take care of your both physical and mental health. Enjoy. If possible, we will meet tomorrow in the weekdays classes. Okay. Bye-bye. Take care. Everyone. Thank you. Thank you very much. चलो ठीक है. अब तुम लोग अच्छे से रहो और